video helpful, please like, subscribe and press the bell icon for notifications. Hello guys, today we will be learning about linear combination and special vectors. So linear combination is the addition of scalar multiple of vectors, or when vectors are multiplied by same scalar or different scalars and then add together, then it is a linear combination of those vectors. Like if u is equals to 1, 2, 3 and v is equals to 0, 1, minus 1 be two vectors, and let a and b be two scalars such that a is multiplied with vector u to get au is equals to a times 1, 2, 3, that is a, 2a, 3a, and b is multiplied with vector v such as bv is equals to b times 0, 1, minus 1, that is 0b minus b. Then au plus bv is equals to a, 2a, 3a plus 0b minus b, which will give us a plus 0, 2a plus b, 3a minus b, and this is a linear combination of vectors u and v, and this will give us infinitely many new vectors because we can substitute any values for a and b here. So we will get infinite vectors. So now graphically, if this is vector u and this is vector v, then let's draw a parallel line to vector v and parallel line to vector u to get a parallelogram. Then this diagonal line is the resultant of u and v. So u plus v is represented by this diagonal. Now let's take a scalar multiple of u and v. So if this is vector u and this is vector v, and if we scalar multiply u with 2 and v with 3, then we will get 2u and 3v. Now let's draw a line parallel to vector 3v and a line parallel to vector 2u. Then this diagonal line is the resultant of 2u and 3v. So 2u plus 3v is represented by this diagonal, and this is the linear combination of u and v. Now let's take another scalar multiple of u and v. So if this is u and this is vector v and this is half of vector u and this is twice of vector v, then draw a line parallel to vector 2v and a line parallel to vector half u. Then this diagonal line represents resultant of half u and 2v. So this diagonal is half u plus 2v. So half u plus 2v is the linear combination of u and v. Similarly, we can get infinite combinations. Now special vectors. So one of the special vector is 0 vector where all the entries are 0, and this vector is associated with origin because all the coordinates are 0 at the origin. So for example, this vector v is equals to 0, 0, 0 or u is equals to 0, 0, both are 0 vectors. Now another type of special vector is elementary vector. So on xy plane, coordinates at unit length along x and y axes are 1, 0 and 0, 1. So this vector along x-axis is elementary vector and it is represented by E1, and this vector along y-axis is represented as E2. So E1 is equal 1, 0, or we can write it vertically to 1, 0. E2 is 0, 1 or 0, 1 vertically. Now in 3D plane with x, y and z axes, coordinates at unit length along x, y and z axes are 1, 0, 0, 0, 1, 0 and 0, 0, 1. So E1, E2, E3 are the vectors along x, y and z axes respectively, where E1 is equals to 1, 0, 0 or 1, 0, 0 vertically. Similarly, E2 is equals to 0, 1, 0. E3 is 0, 0, 1. So as we can see in E1, except first entry, all entries are zeros. In E2, except second, all entries are 0. In E3, except third entry, all entries are 0. So a matrix of the type 1, 0, 0, 0 up to 0, 0, 1, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0, 1 or 0, 0, 0, 0, 1, 0. So as we can see that in first column all entries except the first entry are zeros, so it is E1, and similarly second column is E2, then E3, and last column is En, and this column is En minus 1. So E1 is the elementary vector that has zeros everywhere except in the A11 position where it is 1. Similarly, we can say about E2, E3, E4, E5 up to En. So any vector can be written as a linear combination of E1, E2, E3 up to En with unique coefficients like vector u is equals to 2, 3, 1 can be written as u is equals to 2, 3, 1 is equal to 0, 0 plus 0, 3, 0 plus 0, 0, 1. Now take 2 as a common factor. So we will get 2 times 1, 0, 0 plus 3 times 0, 1, 0 plus 0, 0, 1. So this is vector E1, this is vector E2, this is vector E3. So u is equals to, or vector u is equals to 2 times E1 plus 3 times E2 plus E3. And this is the linear combination of E1, E2 and E3 with coefficients 2, 3 and 1 respectively. So any vector can be written as the linear combination of E1, E2 and E3 with unique coefficients. So guys, in our next video we will be looking into vector equations. Thanks for watching.